Hello friends, welcome to the ATC Double Cut. In today's episode, I am going to discuss clipping volume, which I haven't talked a lot about for a while, and it is about a new blog post that I've put up, and the title of that blog post is Converting Clipping Volume to Dry Weight. You may notice if you're watching this that I'm wearing my University of Tennessee Turfgrass shirt, and I'm going to reference an article that was published this year by some researchers at the University of Tennessee towards the end. But before I talk about that, I just want to talk about clipping volume and dry weight and why I think that this particular blog post is worth your time and this topic is worth your time to be aware of, because it has come to my attention that not everyone is aware of it. And that is a pity, because this is a tremendously useful little turf hack. Clipping volume is a really easy way to measure how much the grass is growing. And for scientific purposes or for research purposes, we don't measure by volume. We don't report that in a scientific article, the volume generally. What we report is the dry weight of the clippings. If you look at a harvest of grass, it's reported as the mass, the dry mass of clippings per area that it was harvested from. And that's how clipping yield is measured. It's always a dry mass. So some researchers, and myself included, have not paid so much attention to volume, and I guess some people are still not paying attention to it, even though there's been research, published and unpublished, that shows that there's a linear relationship between clipping volume and clipping mass. I'll put a direct link to this post in the show notes so you can check it out and you can see what those linear relationships are. And there are direct links to an appendix in my clipping volume book that explains how to do this. There's a link to a post on the Pace Turf website that explains how to do this. There's a link to an article by Chiyu Zhou and Doug Soldat from the research that they did at the University of Wisconsin on creeping bentgrass. And there's also a link to an article by Benjamin Pritchard et al. At the University of Tennessee, where they also established this. So it's something that people have been checking for the last decade or so, and they're finding out that if you measure the clippings and you just put it into a bucket and measure the volume, from that you can predict what the dry weight of those clippings would be. And that is something that I did not realize, which is why I started this blog post with a statement where I said, quote, "One of the reasons I didn't pay attention to clipping volume numbers in my youth was my failure to realize that the volume of clippings is related to the dry weight of clippings." I thought that the volume was not so useful to know the number because I didn't know what I could do with that number, because the number that I wanted to know was the dry weight of the clippings. I wanted to know the dry weight. I did not care about knowing what the volume was. So I would just look in the baskets like everyone does and count the number of empties like everyone does and not pay attention to the number, to the volume, because I didn't know what I could do with it. And I see that people are still persisting with this. In fact, I checked out the Gary Grigg Facebook page, that golf course maintenance group that some of you may have been to, and I saw that on that Facebook page, there is a discussion, an ongoing discussion that was started recently about clipping volume. And some of the people there who are responding, and it's typical, I've heard this before, they say that, they can just tell by their eyes, they don't need to measure it, or they can't quite figure out why you would need to do that. It sounds really complicated, and they think that there's a lot of variables involved. And in fact, it's something like this, which is the second paragraph of my blog post. I wrote, those who don't bother measuring clipping volume today occasionally mention that the volume won't be related to the weight. Quote, too many variables for this to work, end quote, they might say. And then we'll use that misapprehension about clipping volume as one reason not to measure it. And in fact, that quote, too many variables for this to work, I pulled that right from that discussion on Gary Griggs' Golf Course Maintenance Facebook page or Facebook group. I don't often go there because it's my business to give advice that I get paid for, and I try to give very professional advice. And if you pop into that group, my perception of it is a lot of people are sharing information that may not be accurate, and they're giving that bad information away for free. So for me, it's just like a place that I don't check out very often. But every now and then I'll check it out, do a search for some keywords like clipping volume or MLSN, just to see if people are talking about these kind of things. And in this case, I stumbled across, wow, they're talking about clipping volume. Now, it's interesting. I also heard from one of my clients that they have been to a seminar and they heard the speaker mention that there is not a relationship between clipping volume and clipping dry weight, and that what they really want to know is the clipping dry weight when they're doing research, which is absolutely correct in one aspect and completely wrong in another aspect. It's completely correct that you do want to know the dry weight when you're doing research, but it's not correct that clipping volume is not related to the dry weight. So I went on to explain this in the blog post. I said, soon after I started paying attention to clipping volume, that was back in 2013, or almost, it was 11 and a half years ago, basically, when I started paying attention to it. I wanted to check if there was a relationship between volume and dry weight. The Nichi-no-ryoka research facility, which is near Tokyo, Japan, had a drying oven, and I worked with the staff there to design a data collection project that would allow us to describe the linear relationship between volume and dry weight of clippings for multiple species, because they had a test green there that had creeping bentgrass, it had ultra-dwarf Bermuda grass, and it had cori, or manila grass, Zoysia matrella, all maintained at putting green height. So on multiple mowing events in 2015 and in 2016, the clippings were collected, the volume was measured, then the clippings were dried in the drying oven, and the dry mass of those clippings was measured. And from that, we can develop a linear regression equation that will describe the linear relationship between the volume and the dry weight. So from that, we found that 1 liter of bentgrass or Bermuda grass clippings from a putting green would on average have a dry weight of about 60 grams. So if you want to convert 1 liter of clippings to what it would be in grams, you just in dry weight, you can just multiply it by 0.06. And we found that 1 liter of manila grass clippings would have a dry weight of about 110 grams. And that makes sense because manila grass generally has a little bit more dry matter and a little bit less water in the leaves. And so those leaves are a little bit denser. And we followed that up with research in Thailand. We went to Nikanti Golf Club, which has Tiffigal ultra-dwarf Bermuda grass greens. And Brad Revel, the director of agronomy, or maybe he's the consultant there now. He had been the director at some time in the past. He was measuring of course they measure the clipping volume there. So I had him collect the clippings, measure the volume, and send them to the Thailand Institute of Scientific and Technological Research. And there's a drying oven there at that institute, and they were dried, and we checked the relationship, and it turned out it's the same as what we measured in Japan. And then at the University of Wisconsin, Chiyu Zhou and Doug Soldat, they made these measurements, and they also found on creeping bentgrass that it's about 60 grams of dry weight of the clippings for every 1 liter of fresh volume. And then there's an article by Pritchard et al., and they checked on fairway height turf. They had, I believe it was latitude 36 Bermuda grass mown at 13 millimeters or half an inch. And they also had, I think 1 year they did it on Trinity, L1F, Zoysia, and I think the next year they did it on Zorro, Zoysia. And the title of their article is a question. Is there a relationship between clipping weight and volume on golf course fairways? That's the question that they ask. That's the title of their article. And they answer that question with a resounding yes. They conclude, and I quote, significant linear relationships were detected among clipping weight and volume on hybrid Bermuda grass and Manila grass treated with varying formulations of trinexapac ethyl, which is the active ingredient in the Primo Max plant growth regulator. They concluded that assessing the growth suppression by that product would so if they're assessing the efficacy of that product, whether they're using clipping weight or volume, it resulted in similar conclusions, and both assessments captured the majority of variation among the replications of a particular treatment. So it didn't matter whether they measured the volume or the dry weight. They found that there was a linear relationship between the two of them, and it was capturing what was happening with the growth suppression from the Primo. Or in this case, they were experimental formulations of that product. Then they said a lack of difference among the two measurements indicated that either assessment could be used by researchers. Now, of course, it's a lot easier for golf course superintendents or for sports field managers or for lawn aficionados to measure the clipping volume because most people don't have a drying oven, and you can easily measure all of the clippings that you harvest, but it's very difficult. I mean, it's really easy to measure the volume of all of the clippings that you harvest. It's very difficult to dry and then measure the dry mass of all the clippings that you harvest. Plus, dry clippings tend to be contaminated by sand, and because sand has such a higher density than dried grass clippings do, it really throws a lot of error into that measurement. And it has much less error in the volume than it does in the mass. So clipping volume can be so useful. So if you don't know yet, why would you want to know the dry mass? Well, if you know the dry mass, you can calculate the nutrient harvest. So if you calculate the nutrient harvest, you can then calculate how many nutrients you'd need to resupply to make sure that you've replaced 100% of what the grass uses. Or you can check how much the soil should decrease in a particular element based on how much has been harvested. Once you know the dry mass, you can do a lot. So clipping volume on its own is perfectly fine for things like adjusting plant growth regulator applications, for adjusting some of your mowing, for adjusting perhaps some of your sand top dressing applications. You only need the volume. You don't need to convert it to a dry mass. But for nutritional reasons, when you're trying to really fine-tune your turf nutrition plan and making sure that you're supplying the grass with all the nutrients that it can use, then it is extremely useful to have clipping volume data that you then convert to dry mass data, and you can do all kinds of cool things with a lot of precision to predict exactly how many nutrients have been used and how many nutrients the grass should be resupplied with. I put a few links in here, so if you're interested in this, you can check them out. I've written about this before, but those couple of things that I mentioned earlier prompted me to put this together all into one blog post today. I put 3 specific links. One of them is to Appendix B7 in my book, One Bucket at a Time, and the title of Appendix B7 is Estimating Nutrient Use and Harvest. And in that, I describe and work through a couple examples of how you can do that based on clipping volume. I also link to a Pace Turf update, which is for Pace Turf members. And many of you are Pace Turf members. If you're not, you can go to paceturf.org and become one today. The title of that is 3 Simple Ways to Estimate Nutrient Removal, because the exact way that I'm talking about here, well, it's an exact estimation. The exact estimation involves taking your clipping volume and from that converting to dry weight, and then from the dry weight, you can make the calculation of how many nutrients were harvested. But there's other ways that are easy also, and I explain those in that Pace Turf update. And also, I linked to my slide presentation with the title Turfgrass Growth Potential and Measuring Clipping Volume, which is from the 2018 Czech Greenkeepers Association Conference. And in that conference, I shared those slides, and you can scroll through all of those and get not only an overview of clipping volume, but there's an entire section that talks about this relationship between the clipping volume and the clipping dry weight. So this is something that if you are doing clipping volume, if you're measuring clipping volume, you can take the total amount of clippings and convert that into a dry weight, and then that will tell you how it will give you an estimate of how much nitrogen you've harvested, how much potassium the grass has used, how much phosphorus has been removed from the soil every year. And from that, you can get a check on whether your nutrient application rates are sufficient or excessive or insufficient to meet what the grass is actually using. It's a really nice tool. So I encourage you to check out clipping volume if you're not doing it yet. It has all kinds of very practical and informative applications. I will be back again soon with more interesting turfgrass topics, but for now I will sign off for ATC from Trong, Thailand. I'm Michael Woods. Bye-bye.